Good afternoon from 4 students. Okay, this is our second lesson of this week. So I hope everyone's doing fine at home. Okay, enjoy your time, whether you are studying or you are resting at home. Hope everyone happy at home now. Huh? Okay, right. Our last lesson now we started new chapter, right? New chapter is chapter 5, wave. Okay, wave. Okay, before I share something for you all, I want to ask something from you all. Okay, last chapter now, last lesson, we learned this wave, right? Okay, then I want to ask a few questions, see whether you all remember. Don't be scared, don't be scared. Okay, first question. Actually, what is the meaning of wave? W-A-V-E, wave. If people ask what is wave, so how you answer? Wave is what? Ong Chao Xiang. Wave is what actually? Ong Chao Xiang. Huh? What is wave? Huh?
Produced from oscillation.
Yeah, it's yes, correct now. It's a product from oscillation, product from vibration. Okay, anything vibrate, anything oscillate, you can produce a wave. Okay, right. This is one of the answer that is considered correct now. Okay, I want to hear another answer. The meaning of wave. Another answer is what? Terry go. Got another meaning, no? Another definition for wave. What we say is something to do with energy. Something to do with energy. So, what is that? Terry go.
Medium.
Something to do with energy. You think of energy. Waveform.
Transfer energy.
Yes, correct. Wave actually is something can transfer energy from one place to another place. It's also considered a wave. Okay, wave is a form of transferring of energy from one place to another place. That is also a wave, right? Okay, my third question. Wave can be divided into how many categories? How many category of wave? We can divide it to how many categories? Convection. How many category of wave we can divide? Convection. Any idea? Juling, what about you, Juling?
2.
2. Okay, correct. Can you tell me the 2? What are the 2?
Transverse wave, and longitudinal wave.
Yes, correct. One is transverse wave. Another one, we call it longitudinal wave. Longitudinal wave. Longitudinal wave. There are 2 types. One is transverse. Another one is longitudinal. Okay. Then I have another question I want to ask you. What is longitudinal wave? What is that? What is longitudinal wave? Longitudinal wave. You are asked this question. What is longitudinal wave? So how you answer? Hashini? Longitudinal wave. How you answer? Hashini? Hey, Hashini.
Direction of vibration. Can sir?
Yes, correct. Say continue.
Direction of vibration of the particles is parallel to the direction of wave propagation.
Yes, very good answer. The direction of vibration of the particle parallel to the direction of propagation. This kind of wave, we call it longitudinal wave. Can you give one example, Hashini? One example of longitudinal wave. One example. There's only one example only for longitudinal wave. What is that? Huh?
Sound wave.
Sound. Yes, correct. Only sound we can name it under longitudinal wave. Only one sound only. Huh? Okay, another one is transverse wave. What is transverse wave like? Commonly, what is transverse wave? How to give answer transverse wave?
Transverse waves is waves in which the direction of the vibration of the particles is perpendicular to the direction of the wave
Yes,
propagation.
yes, very good. It's a wave where the direction of vibration of particle, right, perpendicular to the direction of propagation. Okay, so that one is transverse wave. Okay, next question. Don't scared, don't scared lah. Don't go and hide. Okay, don't scared. Avril Lim, are you there? Avril?
Yes.
Avril, can you give me two examples of transverse wave? Two examples.
Water wave, electromagnetic wave.
Yes, correct. Water wave and electromagnetic wave. Two types of wave. These two types are considered transverse wave. Okay, one more question. Justin Yip, are you there?
Yes, teacher.
Okay, Justin, can you tell me, give me a few examples of electromagnetic wave?
Ultraviolet rays, infrared, and gamma rays.
Ultraviolet, infrared.
Gamma rays.
Yes, gamma ray. Any more? One more?
Light wave.
Light wave. Yes, correct. There are 7 altogether, electromagnetic wave, radio wave, ultraviolet, infrared, light wave, X-ray, gamma ray, all these are electromagnetic wave, right? Okay, then one more question. Can you tell me now the wave can travel through vacuum? If can travel through vacuum, we call it what type of wave? Can go through vacuum one. So we call it what?
Electromagnetic wave.
Electromagnetic wave. Yes, very good. Next question. Yi Mei Hui, are you there? Yi Mei Hui, Yi Mei Hui, no answer one, or quiet one. Okay. She typed on the mind. Let her type. Okay. Yi Mei Hui, my question. What is a wave cannot travel through vacuum? You cannot travel through vacuum one, we call it what? Cannot travel through vacuum one. So this kind of wave is given a name. So what is the name of the wave cannot travel through vacuum? Yi Mei Hui? Yes, correct. Mechanical wave. She typed there. Yes, very good. Yi Mei Hui, correct. The mechanical wave. Mechanical wave cannot travel through vacuum. Can travel through vacuum one, we call it electromagnetic wave. Justin said just now. Okay. And I got a lot of questions I want to ask, actually. Okay, next one is what is the meanings of amplitude? Amplitude is what? Jin Yi Hong, what is amplitude? Jin Yi Hong? Jin Yi Hong, are you there now? Kian Leong, you are there. Kian Leong?
Yes, sir.
What is amplitude?
The maximum displacement of the medium particles from the equilibrium point.
Yes, correct. Very good answer. It's a maximum displacement from the equilibrium position. So that is called amplitude. Okay, next. Next question is, what is the meanings of period? Hong Chao Xiang, period is what?
The time for one complete oscillation for each particle in the wave.
Yes, very good. Correct. Okay. Time taken for one complete oscillation. Nah, correct. Nah. Then next one is what is frequency, Cherise? Frequency is what, Cherise?
The number of oscillations of each particle in the wave in 1 second.
Yes, correct. Number of oscillation can be made in 1 second. 1 second can make how many oscillations? So we call it frequency, right? A lot more. I got a lot of things to ask you all, you know. Okay, next one is what is wavelength lambda? Wavelength lambda is what? Sima, what is wavelength lambda?
Distance from one wave crest to the next.
Yes, correct. It's a distance between one crest to another crest. Or you can say it's a distance between one trough to another trough. That is one lambda, right? Okay. Then one more question. How to calculate the speed of the wave? To calculate the speed of the wave, what formula we use? Possible? To calculate the speed of the wave, what formula is that? Possible, are you there?
Yes.
Yes. What is the formula to calculate the speed of the wave?
Frequency time wavelength.
Yes, correct. V equal to F lambda. Okay, the thing is called lambda. Wavelength is lambda. So V equal to F lambda is a formula used to calculate the speed of the wave. V equal to F lambda lah. Okay lah. I think you're very scared already now, Mike. Okay, now we continue. We continue where we stopped last lesson. Okay, now we can look at here. We stopped at, I think, this question, example 4. Okay, is it correct or not? Is it true? We stop here, correct? Tian Liang, is it correct? We stop here? Question 4. This question we have finished discuss already, right? Okay.
Yeah, it's already.
Okay, so this one finished. Okay, now next one is something to do with a machine one, you know. You see this, okay. This one. This one need a lot of attention. You all listen, You all can see the whole diagram or not? Okay, this is called a ripple tank. Ripple means wave. Tank means a thing to store water one. Okay, ripple tank means this is a tank can produce a ripple, can produce a wave. So we use a small machine to generate water wave for us to study, you know. Okay, this machine you see, it's like that one. Okay, this is a small container. So you put water up here, got water one, no, you pour water here. You put water here, okay. And then on top here, you have a lamp. You need a lamp on top, okay. And then here you have electric motor. This is a motor, electric motor. And then the motor attached to a wooden bar, vibrating bar. Wood made from a piece of wood, right? Okay, what happens is like this, you know, when you on power supply, this motor connect to power supply. Okay, let's say power supply, you on the power supply, right? So the motor will rotate. But because this motor is already tied up here, the motor cannot move. The motor only can vibrate. When you on the electric, so this motor is supposed to turn one, right? It cannot turn, so it will vibrate. So when this motor vibrates, it will make this wooden bar disturbing the water. It will disturb the water. It will keep touching the water. Okay, keep disturbing the water. Then you can see here got water wave produced. So this water wave is produced by using a vibrating bar. This vibrating bar will keep hitting the water surface, disturb the water surface to produce a water wave. Understand now? Okay, now, actually now, on top here, you want to see the water wave is a bit difficult. Okay, the water wave hard to see one because the wave moving too fast, you cannot see one, you know. So what you see actually, you are looking at a piece of white paper at the bottom here. White paper. You put a piece of white paper here. That's why you put a lamp here. When you put a lamp, this water wave can produce a line like this. Dark color, white color, dark color, white, dark, white, dark. Then you can see the lines like that. So you can see dark color line, then followed by bright. So meaning that it's forming like this. So this is dark, then this is bright, dark, bright, dark, bright, and dark. Like you can see many lines here. Okay, all these lines actually are the shadow formed by the wave on top because of the lamp. When the lamp lighted up them, then form the shadow here. So you can see the lines lah. Dark color, bright color, dark, bright, dark, and bright. Okay. And one more thing. If you using our naked eyes, you want to see this dark and bright line also very difficult because it's too fast. Water wave too fast, you know. It moves too fast, you cannot see one actually. So you need to use a stroboscope. This one is a stroboscope. Okay, this stroboscope is rotating one, it will turn one. Okay, you will keep turning. Okay, you see got many holes here, right? Holes. So your eyes is looking through the holes. Okay. So this thing now, stroboscope will rotate. When the rotation frequency, same as a water frequency, same already. When the speed of rotation here, right, same as the speed of this water wave, then it will something like frozen, freeze. So meaning that you can make this water wave stop moving, you know, like stop moving because this stroboscope turning frequency same as the frequency of the water. When both of them having the same frequency, you know, it will appear like stop moving, and then you can see clearly the line. Bright, dark, you see the line? So that's the important using a stroboscope, you know. The function of this stroboscope is to freeze, we say freeze the wave, something like to stop the wave from moving so that you can see. Okay, how? The answer you must know, you know. When the frequency of rotation of the stroboscope, same as the frequency of the water, right? Same frequency, so it will stop. This thing will stop. Actually, they are not stop, you know, but appear like stop so that you can see the light clearly. So if people ask you what is the function of this stroboscope, so your answer is to freeze the water wave in order let us see the wave easier. That is the reason of stroboscope. Okay, stroboscope means there are many holes here. It keeps turning. So your eyes only can see the wave when the light goes through the hole. Like that, understand? Okay, so now you know this stroboscope function already, right? Okay, when you're using a wooden bar, so you produce straight line wave. So we call it plane wave. Let's say I can take out this I don't need to take out anything on this wooden bar. There's hole, hole that I put in another thing. This is called dipper, a small ball, dipper. This one you can just plug inside here, plug inside. Then this ball touching the water. This is called dipper. Dipper is a small ball used to dip the water, used to disturb the water, dip the water. You see, when you allow the dipper to dip the water, right, it produces circular wave. This is called circular wave. Meaning that this machine can produce two types of wave, you know. One is circular wave, circular shape one, using a tipper. You must know, you know, in the SPM to come out us before one, no. Using a tipper to tip the water, then you can have circular shape wave. Then, if you are allowed this wooden bar, one piece of wood to touch the water, then produce plane wave. Understand? That is a function of plane wave, function of the wooden bar and function of the tipper. Okay? Understand? Justin, understand or not?
Understand.
Can Leong understand?
Understood.
Okay, so you know the machine, the function of this machine already, Ripper tank. Okay, now I got something extra I want to tell you. You listen. When you are using the Ripper tank, when you pour water here, you must make sure the water, the depth must be uniform one, you know. From here to here, make sure the depth of water is uniform. You must make sure, you must place this thing flat so that the depth of the water uniform. If not uniform, all your answer wrong one. So you must make sure the water has the same or equal depth. The reason is it will ensure uniform speed. The water wave will move with the uniform speed. If deep, then shallow, it will affect the speed one, you know. Okay, when the speed of the water different, then something else happen. So you want to see the water wave uniform, right? So you must make sure the water wave can travel with the constant wave, constant speed. How you make the wave move in constant speed? So you make sure the depth of the water uniform. So please jot down. The water must be uniform depth. The reason is to ensure uniform speed of the wave. The wave is uniform speed. Okay, another thing you must learn, okay? Surrounding the tank, right? Surrounding here near the border. So you need to put span. So you put span, you know, line with the span. You put span here, put span here. Why putting the span? Okay, we put the span here to absorb the energy of the wave so that no reflection happen. Because when the wave hit the wall, right, then it will reflect. Then kacau lah, come here, go back, come here, go back. So all kacau become messy, mess up already. So to prevent from reflection, right, you put something spun here to absorb the energy from the wave to prevent the reflection. Okay, the reason So two things, remember Okay, now I want to ask you all, see whether you all got listen or not. Yu Xuan, are you there? Yu Xuan? Yes. Yu Xuan, why we must make sure the water here has uniform depth? Why must have uniform depth, the water?
Not the observation is wrong already. Yeah,
Why wrong? Why must make sure the water, the depth is uniform? Why? That's why I say you got jot down or not? Why the water depth here must be uniform? Why then? Sima, okay, Sima, come on, please. Why water must have uniform deep depth?
To ensure uniform speed.
Yes, correct. Those who never jot down one, you better jot down now. To ensure the wave here has uniform speed. That is very important, uniform speed. Okay. Another thing we do just now, I said we put this span surrounding the water dam, right? So we put span here near the border here, we put span. Why we need to put the span there? Why? Mandy, why put span, Mandy? Mandy, you don't want to talk, never mind, you can type, Mandy. Why put span? Why put span here? Mandy, Mandy Tera, I'm waiting for you or Mandy for answer. Okay, she typed. Let's see what she typed. Yes, correct. Prevent reflection. Okay, absorb the energy, prevent reflection. Very good answer, Mandy. Okay, so remember that. All right. So now we see the detail. And one more question I forgot to ask. What is the function of ripple tank? This thing called ripple tank. For what? What is the function of ripple tank for us to play? Ripple tank function is what? Dong Jia Wei. Ripple tank is for what?
To see the frequency of wave.
See the frequency. Did I say see frequency just now? Or I say something as ripple tank is for what actually? Ken Liang. This ripple tank is for what?
Observe the wave producer.
Yes, correct. To produce a ripple. Ripple means wave lah. To produce a wave. Okay, to produce a wave. To generate the water wave. Okay, that's the reason. All right, now we see the detail. In the lab, to produce water wave, we use ripple tank. Please highlight. You want to produce a wave to study, right? You don't need to go to the sea. No need. You stay in the lab, use a machine. We call ripple tank. This one is ripple tank. All the school have this thing in the school lab one. A shallow tray of clear plastic hold the water here, holding the water here. This is clear plastic, transparent one. Okay, to keep the water. Okay, a shallow tray of clear plastic hold the water, and the light above the water. Got light here. Project the wave pattern on the sheet of white paper below the tank. This lamp project the light, project the wave on a piece of white paper here. That's why I told you just now we look at here. Don't see here, see here. Okay. And then now we have, just now I told you, right? Bright and dark bands, meaning that you can see bright line, dark line, bright, dark, bright and dark. No, it's because it say bright and dark bands. Bands mean the light, the line, okay, of the wave pattern form on the screen. Because this one very important. No, why got dark color? Why got bright color? I think I'll let you see this one first. Okay, look at here. You must know this concept first. I think in lower form you study the lens, right? Okay, let's say this is convex lens. Convex. The convex lens can focus the light. You see, when the light go through, you get focus here. So this is convex lens, focusing the light. And this is concave lens. Concave. Center here very thin one. This one is diverging the light. Okay, it spread out the light. See, it's spread out. Okay, like that. So this is focus. This is spread out. Different lens, convex, concave. So remember that. Okay, now you look at here. On top of the ripple tank, so you have the water wave, right? This water wave. So here on top here got lamp, so the light come down. So when the light come down, you see this one, this is crest. Crest is just like convex lens. If we focus the light, you see, when the light go through this water can act like a lens, it will focus the light here. So all the light focus here, so make this area become bright, very bright. A lot of light there, so it's bright. Okay. Then this one also focus. This one like convex lens, so it will focus the light. Okay. So here become bright also. Then in the center, no light. See all the light here, focus here. The light here, focus here. Here less light, so it become dark color. No light being dark lah. Here become very bright. Here very dark. Here bright again. Here dark again, bright again, dark again, bright again. That's the reason, you know. That's why at the bottom there you see bright and dark bands. This is the reason, because of the water wave. Jadi the water wave here, the crest focus the light. This one is trough. The trough diverge. This one is actually is focus or converge. This is diverge the light. So here no light, so become dark. Okay. B is bright, D is dark. Now, okay, understand or not? Okay, now Mike, so we go back here. The bright and dark bands of the wave pattern form on the screen because, here's a highlight, surface of water act as a lens. Lenses either is convex lens or concave lens. The crest, here, crest, this is crest. Last week you learned like crest. The crest similar with convex lens, like this. Convex lens will focus the light, not focus the light here. And the trough similar with concave lens. This one concave lens. This trough here is concave lens, diverging the light. Okay. And plane wave are produced by straight bar which hung by two elastic band. Use the elastic band to hold this wood, this piece of wood, hold here. Okay. When it vibrates, so it's touching the water. Okay. Okay. Circular wave produced by using a dipper fixed to the bar. Use a dipper to touch the water. Okay. When a continuous stream of wave is used, it's sometimes easier to see by using a stroboscope to freeze the wave. Okay, please highlight. The function of the stroboscope is to freeze the wave pattern when the frequency of the wave same as the frequency of the water. Here is water, you add yourself. Then can I understand this part or not? This one very important. This part, no, this foundation. Once you know this one, understand already, then only you can proceed. We can carry on. So make sure you understand all this first. My room is too cold. I will off the aircon. They're on the fan. Very cold. Okay, then I will charge my laptop. No battery. So okay, now can I understand? Now the whole thing understand or not, everyone? Why this part cannot on? Yeah. Okay, now I let you read the whole thing. I give you some time to digest. Then afterward, I ask you a little bit question. Okay, can or not? You read here, I read here, and then the whole thing here. Okay, in 2 minutes now. You read now. Okay, read this one first. Read now. Okay, read the whole thing. Yeah, this one finish. So I push up another one. Okay. Okay, finish. Yeah. All right. Okay, just a simple question. Don't worry, okay. Don't need to run away. Don't run away, please. Okay. Okay. Ching Han, are you there? Ching Han, no microphone one or she cannot hear one or. For Siu Mei, are you there?
Yes.
Okay, for Siu Mei. My question very simple lah. How to produce a plane water wave? Plane one. Plane means straight line one. How
Plane.
to how to produce a plane wavelet? Use what? How to produce this kind of wave? Plane water wave, straight line one. Use what?
Ripple tank.
Ripple tank is a whole thing, ma. Whole thing is ripple tank. Or you want to produce this kind of wave, so use what? See, I point here is what?
Vibrating bar.
Use a bar. This bar, the motor vibrates, so the bar will touch water lah. This piece of wood will touch water, right? Then you have plane water wave law, correct not?
Yes.
You may understand that. Now you answer my another question. How to produce a circular wavelet? Circular wave, how to produce? Circular wave.
Tipper.
Use a tipper to tip the water, okay? To touch the water, then you have circular wave, okay? Right, these are okay already. Okay, next question. Why under the ripple tank here on this piece of white paper why we can see got dark color line, bright color, dark color, bright color? Why got like that one? Why got dark color, bright color one? Actually, what happened? Who can answer this question? Let me call this who? Chan Yuan Yi, Chan Yuan Yi, are you there? Chan Yuan Yi? Chan Yuan Yi, are you there now? Chan Yuan Yi? No, disappear. Oh, yeah. Also, do want to talk, want to type. Okay, Chan Yuan Yi. Okay, correct. You are there. Ching Han also there. Ching Han and Chan Yuan Yi, two of you lah. Okay, can you explain? If you want to talk, then you type lah. Why got dark color one, bright color, dark color, bright color line here? Why? What is the reason? Why got such thing one? Ching Han and Yuan Yi, can you type the answer? Why you can see dark color line, bright color, dark color, bright color? Why? What is the reason? Why then? No answer come out here, no. Okay, someone type. Let's see what he typed. Yuan Yi say because of the lamp. Yes, it's because of the lamp lah. But you need to explain, how the lamp can produce those light. How the lamp is because of the lamp is correct, but not fully correct. The answer. Nghan got no. Okay, now might ask somebody else. Chao Xiang, are you there? Chao Xiang,
Yes, sir.
Chao
Yes,
Xiang, can
sir.
you explain why got dark, bright line here? Why?
Because the water surface act as lenses.
Yes, because the water surface can act as a lenses, right? So how this water surface produce a bright and produce a dark line? How?
The crest
crest here.
Act as convex lens and
Yes.
trough act as concave lens.
Yes, very good answer. The crest act like a convex lens, focus the light here. So here become bright. Whereas the trough here, trough act like a concave lens. Diverge the light. So here no light already, but the light spread out already. So it becomes dark. So understand, this question you have to know, not sure, come out one and tell you why got dark, okay, dark and bright line. You must know, why the water wave can produce this one, okay? It's because of the water surface actually act as a lens, okay? Okay, that's all. That's what I want to ask only, don't worry. I know some of you very scared, man. Don't scared lah. You cannot answer, you just say, I don't know, that's all. Okay? Yeah? All right, next one. Just how we are summary here, right? We say the stroboscope function to, okay. Some very important question I want to ask. What is the function of the stroboscope? Stroboscope function is what? Sim, are you there? What is the function of the stroboscope? This one, this thing, keep turning one. The stroboscope function is what? What is the function? Convection. Are you there now, Convection?
Yes, sir.
What is the function of this stroboscope? To what?
To freeze the wave pattern.
Yes, correct. To freeze the wave pattern so that easy to be seen, easy to see them now. Freeze it, freeze means not stop moving. Actually, they are not stop moving. It appear like stop moving only, Okay, that is a function of stroboscope, Okay. Just now we say, right, how to freeze the wave, because frequency of the wave same as the frequency of, okay, you see here, same as the frequency of the stroboscope. You appear stationary. Freeze it like appear stationary, right? Yeah. And one more formula you need to learn now. Okay, this formula let me explain to you When you are using stroboscope, you need to use this formula Okay, cancel this stroboscope. This is frequency of water. Equal to number of slit. Number of slit means how many hole the stroboscope, how many hole like this one? 1, 2, 3, 4, 5. 5 slit. So one rotation, the light can go through into your eye 5 times. So one rotation, you see the thing 5 times, so right? The light go through 5 times, isn't it? Then multiply the rotation frequency of the stroboscope. I want to tell you, the frequency of the water, right? How fast the water move, the frequency, water. You have to use this formula to find the frequency of the water. You take NP. N is number of slit. How many slit here? How many holes? 5 means 5 P is rotation frequency of the stroboscope. Meaning that how fast the stroboscope turns. Multiply the number of slit, and then it becomes the frequency of the water. So remember, to find frequency of the water, you take number of slit, multiply the frequency of the stroboscope. This P is frequency of stroboscope. How 1 second turn how many times? Very simple, I tell you. You listen. When this thing is turning 1 round, you can see the wave how many times the light can go through the hole. 1 rotation, you can see 5 times, isn't it? Because of 5 slit, 5 slit means this one turn 1 rotation, you see 5 times. The light go through your eye 5 times. And let's say this thing frequency is 5, 10. 10 means 1 second, this thing make 10 rotation. That means altogether you can see how many times already? 1 second, you can see how many times? 1 rotation, you see 5 times. if the frequency of rotation is 10 means 1 second make 10 turns. So 10 turns means you can see how many times already. Yan Liang.
Yes.
Here you got 5 slit. Let's say
Yeah.
this 5 slit means you can see 5 times one rotation, correct not? Let's say this one make 10 turns in 1 second. So that means 1 second you can see how many times?
50.
50 times, so correct not? The sign is 5 times 10. N is 5. P is 10. 5 times 10, you get 50 lah. Understand? So you take the number of slit, multiply the frequency of the stroboscope. Then you get the frequency of the water. This formula, you remember, huh? Okay, now this question. Yes, understand it. This is something a little bit difficult to understand, huh? Okay. A mechanical stroboscope had 8 slit, got 8 hole, not 5, 8 slit, and rotate at a frequency of 5 hertz. 5 hertz means this thing make 5 rotation in 1 second. The stroboscope is used to observe the water wave. The observer notes there are 6 successive bright bands at a distance of 12. Calculate the speed. This one a bit difficult. What is the meaning of 6 successive bright bands at a distance of 12 here? Meaning that is here. Bright, 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 bright. So you have 6 successive bright. Okay, 12 cm. In this 6 successive bright, you draw bright, dark, bright, dark, bright, dark like that. So, but we don't care the dark bright only. 1, 2, 3, 4, 5, 6. 6 bright bands. Distance is 12 cm. Then in 6 bright bands, there are 5 lambda. Lambda, you count like this, From one bright to another bright is called 1 lambda, 1 wavelength. So 1, 2, 3, 4, 5. 5 lambda, 5 wavelength. Always minus 1, remember. When you have 6 successive, so the lambda is 6 minus 5, so you have 5. When you have 10 successive, means you have 9 lambda. Always minus 1, remember that, 5 lambda is 12, so 1 lambda is 2.5, no? So you get the lambda here. And then here to find the frequency of water. Not this one, this is the frequency of stroboscope, not the frequency of water. So tak boleh pakai this. So to find the frequency of water, you take NP. N is 8 slit. Number of rotation 1 second is 5. You say 5, right? 5 rotation. Frequency is 5, right? 5, no? So it's 40 hertz. This is the frequency of water. Now you have frequency of water. You have lambda water, then find the speed UV, go to F lambda. F40 lambda 2.4, so you get 96. Okay, copy down the answer, please. Understand this question, very important. Okay, okay, now we answer the question, the objective question. Question 1, what is the answer? Which of the following is transverse different from longitudinal? Which one is the answer? How the transverse wave different from the longitudinal? Zhao Xiang, what answer? Zhao Xiang.
D.
Yes, correct. Donkey. The direction of vibration different. Direction of vibration and direction of wave propagation different. Transverse is perpendicular. Longitudinal is parallel. So they are different. Okay, number 2. Figure show a slinky spring. A slinky spring means a long spring like that. Very long one. So we call it slinky spring. Okay, like this one. You call slinky spring. Backward and downward to produce a model of wave. You move the spring like this long. You see, you move the spring. When you move forward, backward, forward, but you keep moving like that. So the spring will become like this. Then you can see here, combine. Here open up. Here combine. Open up, combine. Okay, like that. Right? Okay, now the question. Which of the following is true? So which one is correct? When you see something like this, so which one is correct? And Choming, which one is the answer? Choming?
A, sir.
A, let's see. Yes, correct. A. The answer is A. Wave is longitudinal. And the direction is parallel. Direction of propagation and the direction of vibration is parallel. Okay, This one okay, A. Okay, number 3. So which one is the answer? In which of the following pair, the first is transverse, the second is longitudinal. So which one? First one is transverse, the second one longitudinal. So which one? Ashini, which one is the answer?
C, sir.
Again, come again.
C.
Yes, correct. C. X-ray. Transverse is X-ray because X-ray is electromagnetic wave. X-rays belong to electromagnetic, so it's transverse. Longitudinal only one sound. I told you, right? You remember or not? The only sound, only wave longitudinal is sound wave. Okay, no other. Next, number 4. Which points are one wavelength apart? One lambda, one wavelength. So you see the diagram I already put here. One wavelength, one lambda actually from P to S, or Q to T, or R to U. Why then? Because I see P to S are like this. This is one complete oscillation. From here you go down, go up. This one oscillation. So it's one lambda. Like this also one complete oscillation. Go down, go up, go down again. This one also one complete oscillation. So it's also one lambda. Another one you can say is trough to trough, crest to crest. This is crest to crest, so it's one lambda. This is trough to trough, also lambda. Understand? So the answer, the only here you can see is QT, right? Correct? QT. Q to T is one lambda. Actually, you can find 3 answers here: PS, QT, or RU. Okay. Okay. Next question. Why the answer is 30? Okay, you study the answer first, then you explain to me. Why the answer 30? I want you to explain why the lambda is 30. Okay. Okay, now Can are you there? Can are you there?
Yes, sir.
Can you tell me why the answer is 30 then? Why the answer is 30?
Because this C divide by 2.
Yes, correct. 60 divided by 2 law, because here got 1 lambda, here 1 lambda. So 2 lambda, 60, 1 lambda is 30 lah. Okay, very easy lah. Oh. Okay, next question. This question very hard to understand. Okay, you all listen to me. Those who sleep one, you better wake up now. Don't sleep anymore. This question you have to listen. Okay, from this diagram, this is a wave. Yeah, you draw a center line. This is amplitude. From equilibrium position, you draw. Then this one is called amplitude. So it's 6 divided by 2 lah. So it's 3. It must be 3. Amplitude must be 3. Okay. So yeah, and then the wavelength lambda, you have to see like this, From here, one complete oscillator here to here, 1 lambda. Here to here, another 1 lambda. Okay, so here is 1 lambda. One complete oscillation, I remember is 1 lambda. Here is a 1. Then here to here is 3/4 lambda. This is not 1 whole lambda, it's 3/4 only. 3/4, 3/4 lah. Because from here to here only is 1 lambda, but now it's 3/4. So altogether is 2 and 3/4 lambda. Okay, from here to here 1, 2, this is 3/4. So 2 and 3/4 lambda lah. 2 and 3/4 lambda equal to 22 cm. So use calculator, 1 lambda is 8. So it's 8. So the answer C. Understand? Okay? Then now, Chao Xiang, understand?
Yes, sir. Understood.
Okay, good. Can one you understand? Can you understand or not?
Yes, sir.
Okay, good lah. So we move on Okay, number 7. Some calculation. So I think your C can understand all. Okay, understand it now. Speed 300. Vibrate frequency 0.6 kilo means 600 lah. What is the wavelength? I use this formula. V equal to F lambda, V 300, frequency 600, find the lambda 0.5. Okay, very simple lah. Okay.
Sir. Sir.
Yes.
Just now the number 6 how to know is 3/4, but 3/4
okay,
the last one.
Come, let me explain. Okay, you can divide this like this law is here. Here to here is half, correct not? Half lambda, correct not? Then here is another half. Okay, you divide to 4 sections. 1 here, 2, 3, 4. Altogether 4. 1, 2, 3, 4. So from here to here is 3/4 lah. Understand Yong?
Okay.
Then 3/4. So you divide to 4 sections now. 1 here, another one is here, another one is here, another one. So 4. So here is 3/4 lah. Okay, 3/4. Then Jiawei, understand?
understand.
Okay. Now, number 8. Also, straight away, very straightforward. Just see the formula, get the answer. Dolphin emits ultrasonic wave with ultrasonic means high frequency wave. Wavelength 0.01 lambda. Speed 1005. Find the frequency. Use the same formula V equal to F lambda. V 1005. Frequency you are asked to find lambda 0.01. So use calculator, you get this answer. Okay, straightforward. So only use this formula V equal to F lambda. Okay. Ashini, can you understand?
Can, sir.
Okay, good. Okay, number 9. What is the speed of the wave to find the speed? Okay, once again, given here now, the make 10 complete up and down movement in 1 second. In 1 second, make 10 times up and down, mean frequency is 10. Because in 1 second can make 10 times, so frequency is 10. Okay. And now from here, you must find the lambda, Because to find the speed, you must know F lambda. F is 10. Lambda, get from here. Okay. Here, from here to here is 2 lambda. So 1 lambda, 0.4, correct not? You see, 1 complete oscillation. So here is 1 lambda, 0.4. Here is another 1 lambda. Or we say crest to crest, also can. Here, crest to crest. So it's 1 lambda. So 1 lambda, 0.4. So you get 4 answer. Okay. Understand? Right? Understand? Tiếng Hàn,
Yes, sir.
understand? Tiếng Hàn à? Tiếng Hàn I think no sound. I didn't see the microphone. That means something, no microphone. Then now mic. Có là? Tiếng Hàn? Yes, sir. Okay. You understand? Okay. Tiếng Hàn, good. Next, number 10. Also straightforward, use a formula. I told you now, it's just now 11 successive bright bands got 11 bright. So meaning that 11 minus 10 minus 1, so it's 10 lambda. 10 lambda is 20. So wait, always remember 11 successive bright bands are got 11. 1, 2, 3, count until 11 bright bands. Then you count the lambda there, got 10 lambda. 1 less 1. Okay. 10 lambda equal to 20 cm. 1 lambda is 2. And frequency is said, vibrator vibrate at 8 vibration per second with the frequency is 8 log. So when you have frequency, you have lambda, you can find the speed V equal to F lambda. Okay, put in, get 16. Okay, quite straightforward now. Can you understand now? Thì mày Huy understand? Thì mày Huy understand now? Yes, sir. Okay, thank you, Imei Hui. Okay, 11. This one another difficult question. Yes, how to get the answer? See, study carefully. Diagram shows strict line represent the position at one instant of successive crests traveling on water. The wave travel at a distance 45 cm in 3 seconds. You see now, in 3 seconds can move 45 cm, then you can find the speed. You take the speed is distance divided by time. 45 cm distance times 3 seconds, so you get 15 cm per second. You get the speed already. From this information, you can find the speed. You distance divided by time. Then here, once again, see how many lambda, be careful. Because the 12 cm start from center point here or not. From this center point to this center point, so you count carefully. How many lambda? 1, 2, 3, 4, 5, 6 lambda. So 6 lambda equal to 12 cm. Okay, please go and understand it. Why here I say 6 lambda? It's from center to center. You cannot count number of line already. You cannot say 1, 2, 3, 4, 5, 6, 7, 8. Then you say 8 should be 7 ma. But it doesn't start from the side, it starts from the center to the center here. So you only take here. So you cannot take all the 8 lines. No, cannot. So take from center here to center here. So you count carefully here, actually 6 lambda. So 1 lambda 12 lah. So put in V go to F lambda. V is 15, get from here. Lambda 2, so you get 7.5. Series, understand? Series, are you there now?
Yes, sir.
Can you understand, Series?
Yes, understood.
Okay, thank you. Very good. Yeah. Okay, next question. 12. Which graph show relationship between frequency and wavelength lambda? Last week I told you already. What is the relation between frequency and lambda? You see this formula. V equal frequency F and wavelength lambda. You want to see frequency and lambda, you cannot put them together. So you take this frequency over here. So it becomes, F become at the bottom, right? And then equal to lambda. And now you can see what is the relation between frequency and the lambda like this. One at the bottom, one on top here. So the relation is what? Inversely proportional, correct not? Like this is inversely proportional. Okay, this one at the bottom, this one on top. So it's inversely proportional. So which graph show the inversely proportional? Which graph? Which graph show the answer? Cheris, can you try? Which graph show inversely proportional graph? Cheris? Try now. What answer?
D.
D. Okay, let's see. Cheris said D. Okay, let us see. Yes, correct. Donkey, correct. That D. Very good. Okay. This answer, inversely proportional graph is a curve go down. This one inversely proportional. Okay, this one up, this one down, so inversely proportional. Okay. Okay, number 13. 13 is a difficult question. Okay, come listen carefully. Don't sleep. Don't run away. A tipper is like this. Tip water to produce circular wave. Going up and down, make wave in the ripple tank. What will happen when the tipper frequency decrease, slow down? Okay, you see these two diagrams. When you tip the water very fast, you see the wave very close. When you slow down and you tip very slow, you see the wave very far one, you know. Okay, very far means actually this one, the distance is called lambda. This is lambda, you know. This distance is lambda, okay? This one is lambda, okay? So this lambda is big, this lambda is small. So now you can see here now, when fast, the frequency high, the lambda small. slow, the frequency is low, right? Then the lambda peak. As just now we say inversely proportional frequency and lambda. So now they say, what will happen when deeper frequency decrease? You decrease the frequency, so the lambda become bigger. When lambda become bigger, so the answer is A. Wave be far apart each other. Far apart means further off, the lambda become bigger. Understand? They pick out the diagram. Yeah. Which in Hong many time or in out. I don't know why. Line problem. Yeah. Some understand the whole question already. 13. Kelvin Lim, understand or not? Kelvin, do you understand this 13?
Of course, sir.
Can I understand?
Of course, I understand, sir.
Okay, very good, Kelvin Lim. Sherry's laughing already. Sherry's, you know Kelvin Lim one or not? You know his same school one, isn't it? Kelvin, Sherry's,
Yeah,
you know him or not?
Yes.
Are you same class with him?
Yeah, same class.
Oh, then good. Good now then. Same class then okay. Sure, I'm sure can understand now. Okay, number 14. This stupid question, they ask so many things, then the answer X is reflection, correct? No? This one compression, reflection, compression, reflection, compression. You understand, huh? So the answer is X is reflection. Transverse wave, wrong. This one is not transverse. This is what? Longitudinal wave, correct? Not? Wavelength 1.2 also wrong. Actually, 1.2 here got how many wavelength? Kelvin, how many wavelength here? 1.2 meter here, actually, how many wavelength?
2, sir.
2, yes. 1, 2, it should be 2 wavelength. But here say 1 wavelength, 1.2, so it's wrong already. The speed 250, you calculate up, you go to F lambda, I don't think it's correct now. Right? Also not correct. So the only correct X is reflection. That's it. Yeah. Okay, number 15. Observe first. You observe. See first, okay? Okay. I'm sure some of you wondering already. Why now here I put T pula? Why not lambda already? So some got one question like this. We say it's lambda, correct not? No, you can see here. Like that we can see this one is lambda. Remember now, when this one is distant, then this one become lambda. Huh? Remember now? Don't be so stupid, gonna cheated, you know. When this one is distant, then this one is called lambda. Now for this question, this one is time. Not distant already. This is time. But then one complete oscillation is time taken, time taken for one oscillation. So you call it period. Period also can take from here, like this also one complete oscillation now. This one is also period. Not lambda line, is period T. Okay, period. So remember when this is time, this one is period. Period, don't confuse, this is amplitude. Okay, so now the question, which of the following is true? When you all do some calculation, I see A, B, C, D, which one is true? Only one correct answer. Which one is correct? Okay, now I show you the whole thing now. almost 10 o'clock already, so I want to go faster a little bit. The answer C. Period 25 wrong, because period supposed to be up to here only, not 25. You see here? Here to here, actually period is 25 minus 5 is 20. So this one wrong. Amplitude 0.4, so wrong. Amplitude should be 0.2 only. Wrong. Frequency you calculate. F equal to 1 over period. You learn this formula also, right? 1 divided by period. So you get 0.05 hertz. So this is correct. So C. Okay. Can you understand?
Yes, sir.
Okay, louder lah. Can you no energy? Why? Yeah, number 16. Which figure show graph displacement distance graph? This one displacement distance, the graph. Okay. The graph is here. Now remember, this one is distance, not time. Now this one becomes lambda, you see? Okay, because this one is distance, so I name this one as lambda. One example, transverse, so you can put water or electromagnetic wave, either one. Amplitude here, 12. Okay, wavelength here to here, 16. Okay. Yeah. Then calculate the speed. V equal to F lambda, substitute, get 400. Yeah. So no problem to understand, right? Sima, understand the whole thing?
Understand, sir.
Understand. Good. Okay, Sima. Okay, copy down already. Okay, next one. Give one example. So answer, I give that tsunami. Why tsunami? Then I give you the answer. I want you to explain. Why is tsunami? Why so many? I don't know. I write tsunami. Kevin Lim. Why the answer is
because the energy transferred during the vibration of the seabed causes water waves.
Yes, correct. And then it's horrible, you see during tsunami, how strong the water wave comes, isn't it? So when the water wave comes, tsunami time, it destroys everything. One house, even a big ship also can be shifted one, okay? A bridge, building are all destroyed. So carry a lot of energy, okay? Tsunami. Yeah. Next, 17. Okay. Figure shows a student setting up wave on a long elastic cord. Just a long elastic cord, so he shake his hand now. Okay. So he tied it up here. Then he move his hand up and down, so produce a wave. When you have a string, you can move your hand up and down like this, you can produce a wave, isn't it? The student can make 5 complete up and down movement in 2.5 seconds. This is not frequency, Frequency is in 1 second. This one is in 2.5 seconds. So you must divide by 2.5. To find 1 second, how many times? So divide by 2.5, you get 2. So the frequency is 2 hertz. Remember now, every time when asked about frequency, right, it must refer to 1 second one. So you have to divide by 2.5 to get 1 second. So you get 2 hertz. Each up and down move a height 0.4. Here to here 0.4. That means half is 0.2 amplitude. Right? Now first question. What types of wave go up, go down like this? Vibration perpendicular to the propagation, so it's transverse. 2 points that out of phase. Out of phase means different timing one. See, P going up, R going up, T going up. This one same direction. Same direction means they are in phase. This one is in phase. Whereas this one different direction. This one go up, this one go down. This one different direction, no? So it's out of phase. The timing and direction also different, so it's out of phase lah. Okay, out of phase, right? Then you see lambda 0.6. How I get 0.6 there? Here is 3. You see, from here you start 1 complete oscillation. So 1 lambda here, 1, 2, 3, and then half. So through 3.5 lambda. I showed it again. Start from here, the wave go down, go up, go down, or 1 lambda. Down again, go up again, down again, 1 lambda, 2 already. Here, another lambda. Then here, half only. So altogether, 3.5 lambda. You understand? Yong Jiawei, understand this is 3.5 lambda? Yong Jiawei, understand?
Understand.
Understand, So 1 lambda, you get 0.6. Okay, then I'm sure they ask you to calculate, right? Okay, Got all this down already? Okay, we move to the next part. Okay, amplitude 0.4 divided by 2, so 0.2 lah. 0.4 divided by 2, sorry. Frequency, also we have done it just now. 5 divided by 2.5. You want to find in 1 second, divide by 2.5 to 2 hertz. Speed, V equal to F lambda, frequency 2, lambda 0.6. So you get 1.2 meter per second. Okay. And the last, what happened to distance PR when frequency of the wave increase the frequency? One thing you must know, I told you just now, when you increase frequency, lambda becomes small. The valid one, inversely proportional frequency and lambda. Frequency will increase, the lambda decreases because PR actually is the lambda. PR, you see the diagram, PR. They ask you what happened to PR. PR is lambda, right? Crest to crest, crest to crest, so it's 1 lambda, correct not? So what happened to PR mean the lambda, so is the answer, lambda decreases, okay? Okay, so answer here. Okay, 10 o'clock already, so I think we have to stop already. Okay, got down all the answer. Okay, finish, All right. Okay, now come back here, Anyone, anything to ask or not? Any question? Any question to ask? Kevin Lim, anything to ask or not? Teacher, can you explain again question 17B? 17B. Okay, let's see. 17B. This one, right? B. Oh, out of phase. Can see or not? Come on, you can see the diagram.
Yes, sir.
Can see, Okay. B 2 point out of phase. Out of phase means move in different direction. You see P move, actually the wave move up, move this direction. Q the wave move down, correct not? Move down. Okay. So this one move up, this one move down. So not moving to the same direction. So they are out of phase. Understand? Like this one, P and R. Okay, same as you move up. Here also move up. So these two are in phase. Same direction, same timing. So in phase. P and Q, different direction. So it's out of phase. Can you understand? Understand now?
Teacher, point out and S cannot.
R and can. R and S also can. Yes, can. You can give P and Q or R and S also out of phase. Can. Okay, understand?
Yes, I understand.
Okay, so settle lah. Okay lah, everyone. So if no more questions, so okay lah. Thank you very much for follow the lesson from the beginning until now. Okay. Take good care of yourself. Okay. Enjoy your time stay at home, whether you study or you play at home. Okay. Enjoy lah. Take good care. Okay. So I see you again next week. Okay. Bye bye. Bye bye, class.
Bye bye. Thank you, sir. Good
Thank
night,
you,
sir.
sir.
Bye bye. Bye bye.
Thank you, sir. Thank you,
Yes.
sir.
Bye bye. Bye bye. Okay. Bye bye.
Thank you, sir.
Yes. Bye bye. Okay. Bye bye.